Yeah, I'm online. Cool. So that's awesome. So today I thought it would be cool to look at fractals. So there's a very simple fractal pattern called the paper folding fractal. And as the name implies, it comes from the concept of folding paper. So yeah, so you can see sort of here, if you fold a piece of paper in half, and then unfold it to like a 90-degree angle, you get one iteration. If you do it multiple times, you can sort of see that a pattern kind of emerges. Let's just see if there's a better thing. So, oh, that's not very good, is it? So anyway, looking at this, so one fold, you get this pattern. Two folds. So if you unfold the piece of paper again, so this part, which is the same as this, it unfolds there. And if you take this pattern and unfold the same thing again by 90 degrees, we get this, and the pattern repeats. So, and it gets quite cool looking as well. So this is what it looks like. Yeah, so it's kind of a funky pattern. I think it's called the dragon, also. So I guess somebody at some point thought it looked a bit like a dragon. So that's what we're going to be going for today. So let's get into it. Just close the stuff down. And so I've got a basic outline here. So it's just an HTML document. I've served up the page just using HTTP server, so node module HTTP server, and I've got the file in just a directory. So that's fine. So that's all the file contains at the moment, and yeah, let's get to it. So I think so I've got a canvas here, so that's what we're going to be using to generate the graphics. I guess a good starting point is to just get some kind of geometry on the screen so that we can see something actually happening. So if we just do equals document dot get element by ID, and we specify my canvas, we can also get the context of the canvas. Get context, a 2D context, and we can just do, so we'll set a line width to equal 1, and let's just set the stroke style to give it a color. Let's just for the moment go with green, RGB. So that's green. Then we'll draw a line. Draw context, begin path, and yeah, that's that. Context dot it's move to, and then we specify some points. So let's just go 2020. I mean, this is obviously just a starting point. So move to moves the line 2. So move to moves like the pen to the position before actually placing it down. And when you do line 2, you actually draw a line from where you currently are to the new location. So we can say, I don't know, 200 to 200. So we're going to be expecting a diagonal line. So the origin is in the top left hand corner of the canvas, pixel 2020, diagonally down across the page to pixel 200 200. So then we're going to give the command stroke. So I think it kind of buffers things and, you know, sets it up that you're going to do this set of actions, and then the stroke command actually does the stroke. So we can go to here, refresh the page, and voila, we have a line. How cool is that? So this gives us a way to draw lines. So why don't we have an array of, so each of these positions is effectively a point. It's a two-dimensional thing. So I think we could create a array of points. So if we go var points equals a new array, and let's give it some points. So we can say x is 0, y is 0. Oh well, let's just go with 20 and 20, just why not? And we'll add those 2 points. So this may not look any different, but it just is more scalable. So now what we can do is we can set the line width and the stroke style, and we'll just do a line for, let's go let equals 0, I is less than points dot length, and I plus plus. So now we've got a little loop. In fact, something I just thought of is we're going to need to start. Yeah, so if we've got 2 points, that's 1 line. If we've got 3 points, that's 2 lines. So we're always going to end up with 1 less line than the number of points that we have, because you always need 2 points for the original line. So with that in mind, I think we need to, we could do it 0 based or 1 based. So yeah, let's start with I equals 1, and we'll do, well, we're going to be using the object that we've got. So we can do points I minus 1 dot x, I minus 1 dot y. And then here we just remove the minus 1 because we're moving to the next point. So I'm just going to alter one of these values so that we see a change when we refresh the page, which we did. So yeah, we can see it's working now with our array. So that's great. What next? Well, I suppose for our paper folding algorithm, let's just say we're going to want like a standard line segment length that we can refer to later. So let's just go segment length const. Segment length equals, let's just say 40, why not? And yeah, that's pretty good. So we'll go here and let's just define the next point in terms of the segment length. So we can go, yeah, so I don't know, I just kind of want to neaten this up. So let's just go, we'll set an origin equal to that. And we can say the first point is origin. And let's just define this in terms of origin. And actually, it occurs to me that what is going to be useful going forward is a way to manipulate points. So I think we can add a function just up here, a function called add points. And we'll give it a start. Well, let's just go A, B. Yeah, A and B. That'd be fine. And we can go return. So we want to return a new point based on the values of a and b. So we can do a dot x plus, well, actually it'd be x equals a dot x plus b dot x, and y would equal a dot y plus b dot y. So this is a handy little utility function we can now refer to. And what we can now do here is we can say, okay, well, the next point is going to be the origin point, origin, plus some other point. So we can go segment length. And so this is going to be like a deflection value. And we'll do a deflection in the y-axis of 0. So this is going to draw horizontally across the screen by 40 pixels in theory. Yeah, now I've noticed that that is gray, a little bit sort of grayed out, which is a bit weird. And I'm remembering now that canvas pixels, so the middle of the pixel is actually 0.5 pixels offset. So you actually have to specify in, well, I can conveniently do it here in the origin actually, can't I? Here, 0.5 extra, so that's the center of the pixel. So where it's on the borderline between pixels, it's just, you've got some anti-aliasing going on there. So now if I refresh, it's a solid green, bright green line. So perfect. Doesn't look much like a fractal though at this point. So what do we need to do now? So I think we've got this array of points, and the algorithm for creating the paper folding fractal is to take the existing structure and to rotate it about the end point by 90 degrees. So that's what we need to do. We need to take these points and we need to rotate those points around the end by 90 degrees and append those points to the array. So I think that's a function that we need, and let's call it unfold, because why not? And we will pass in our points. So up here I can create a function called unfold, and we'll put in our points. And now we need to do the unfolding here. So I suppose the first thing I think of is we're probably going to want to repeat this unfolding process. So this is likely to be some kind of a recursive algorithm. So let's have an iterations argument. And let's initially pass in 3, let's say. And we are going to return from here when iterations is less than or equal to 0. Okay, so that's going to be our escape when we actually have iterated the, I don't know, let's call it times actually. Unfold a number of times. So, oh, I'm thick, and what am I on about? If that is this and that, return. That's what we want. Okay. So, and I guess we're going to want to recurse at the end after we've done one unfolding operation times minus 1. So that's going to eventually escape out of that. So the recursion isn't going to recurse forever. So now we do the actual unfolding. So I guess we're going to need to get an origin point to rotate around. So we could use the last point. So points dot length -1. That would make sense. So get a point to rotate the other remaining points about around. Rotate the points. So, right, I'm going to get, in fact, I'm going to do an example here because I was thinking about this, how to describe the rotation. And let's just say you start off with a, so if you think of an XY, set of XY axes, and if you were to rotate about the center point of that axis, say you had point, I don't know, 4 in the X direction, 3 in the Y direction. Let's just put that down. 4,3. So that would be sort of somewhere up here, I guess. So if you rotated that 90 degrees anti-clockwise, so that way, you'd end up with a point that was deflected 4 in the Y-axis, and it would be -3 in the X-axis. So you'd end up with -3 and a Y coordinate of 4. So then, if you did that again, you'd end up with, so the point that was over here somewhere, if you rotate it again, so it would be -4 in the X direction and -3 in the Y direction. So we can go -4, -3. Then finally, if you rotate it one more time, so if you had -4 in the X direction and -3 in the Y direction, you'd end up with +3. Let me just get this right. So so -4 in the Y direction and +3. So +3, -4, +3, -4. And there's a pattern here. So you can see here, so, and this goes all the way back to the beginning, I think. So when you rotate anti-clockwise by 90 degrees, the Y coordinate becomes whatever the X coordinate was. So here, so this is X. In the next line, Y becomes X. And here, Y becomes the X. And again here, Y becomes whatever the X was. And if we loop back to the beginning, here, this Y value becomes whatever the X was. But what happens with X? So if we take here, X becomes the previous Y value, but negative. X becomes the previous Y value, but negative. X becomes the previous Y value, but negative. 2 negatives make a positive. Then this X value becomes negative of the Y value that was previous. So we've actually got a little pattern here that we can use to do our rotation. So that's quite cool, but that assumes an origin of 0, 0. So we probably need to do the rotation by firstly moving wherever the point is to 0, 0, do the rotation, and then move it back again. So I think that's what we can do. So let's think about how to do that then. So we're going to need a loop. I'll leave that there just for now. Let I equal points.length. Well, we've already got this point, so we've chosen that as the origin. So we don't need to rotate this point. So actually, the first point we want to move is the one before that. So points -2. And we want to keep iterating whilst I is at least 0, and we're iterating backwards from the end of the array, yeah, down to the 0. So that's cool. Now, I think what we want to do is calculate this offset. So whatever the point actually is, we want to express that point relative to this origin over here so that we're rotating about that point. So for example, if I just get paint, lowly humble paint. So if I was to draw, I don't know, this shape, and this is, well, let's just make it easy. So let's say this is X and Y. This point here, if I was to try and rotate around that point, what I kind of want to do is calculate this. So I need to know this distance and this distance so that I can subtract all of these other points, so that I can subtract this X distance and this Y distance from all of these other points. Then I've got this shape here. Then I can do my rotation calculation. Once it's complete, I can then offset it back to its original location. So that will then perform the rotation around this point, which is what we're after. I've completely drawn that the wrong way, haven't I? Yeah, like that. Cool. So let's do it. I guess in order to do that, then let's create a value. So get the relative position of X and Y. We'll call it const. Well, we'll just do delta equals. Now we have, so what we need to do is subtract the origin from the point. So we've got an add points, but maybe we need a subtract points. So let's add it. Subtract points. So we're just going to take one from the other. Hey, that was easy. Subtract points. So now we can get the delta is often used as a like a relative sort of thing. So that's why I've chosen that as the name. We'll go points I as the thing we're going to subtract from, and origin is the value that we're going to subtract. So yeah, just going back to this diagram. So say we're looking at this point, we're effectively going to subtract, let's call that 3, this is 4, and let's pretend that's 3 and 3. So if we deduct 3 and 4 from the X and Y coordinates, you're going to end up with a value of Y equals 0 and X equals -1, which would be here, which is what we're after. Yeah, so that makes perfect sense. So, what do we want to do next? we can implement our little algorithm that we did here. So we need to now calculate the new X and Y coordinates using the method that we just talked about. So calculate new position, and we'll do let new points, new point equals, well, it has a X and a Y. And what do we know? We know that the X value equals the negative of the Y. So negative delta Y. And the Y coordinate equals the X coordinate. See? So we can change that to X. So that's actually performed the rotation, which is kind of amazing. It's so simple. And now what we need to do when we want to actually push the newly calculated point back on the array. So remember, what we're actually doing here is we're taking this. Let's do a different color. We're taking this, and we'll zoom in a little bit actually. Why not? We're taking this shape and we're trying to rotate it into this position here. That's what we're trying to do. So when we calculate this position, we shunt it off down here, calculate the rotation, which puts it here. Then we want to shove it back to, not there, sorry, to here actually, isn't it? Yeah. Yeah, puts it back there. So that's what we're doing. Now we need to put the put it back in our array. So and yeah, we're of course going to do that for each, and we're going to end up with a new longer version of this paper folding, with a set of points that represents the paper folding algorithm. And then when we hit the next iteration, we're going to take this whole set of points, we're going to move it down to this origin here, we're going to rotate it 90 degrees, and we'll end up with I'm not going to try and draw it, rotated 90 degrees. So sorry, it's a bit messy, but that's what we're going to do. So we're going to convert back to absolute position and add to the points array. So points.push, we might as well do it. Add points, we can use our function from earlier. And we're going to do new point, and we're going to add on the origin. So that should actually be the complete algorithm, I think. And we can, let's test it. And amazingly, it's actually worked. So it's shot off the top because the origin is sort of just plucked out of thin air. And look at that. How cool is that? So now we can add more iterations. Let's just go 8. Let's go crazy. Why not? Oh, look at that. So that looks pretty awesome. Kind of bugs me. We've got this gaping void at the top. So let's just reduce that a bit. I don't know. Let's go, yeah, 200. Let's try that. Oh, I actually changed the wrong one, haven't I? That's actually right. Oh, no, I haven't. I'm thick. Yeah, how cool is that? So one thing I think I want to do actually, rather than, because as soon as I change this, this is going to mess up the position. So we need a better way to do that. So I'm thinking there ought to be a way. Yeah, I think what we can do is add a function to offset the points to a particular offset location. We'll just go offset. That can be the offset location. So what we want to do, I think, is what do we want to do? We need to iterate over all of the points, keep track of exactly where the top left corner is of the structure that we've created, and use that to move the entire thing by some value. So we can do that. So I'm just going to set up a top left corner variable. We may as well just set it as well, we need a copy, so let's just do, we can't use the original points. Let's just do, oops. So the reason I'm doing it this way, so I'm using the origin. So I'm picking a random point essentially and saying, okay, we'll assume that's the top left corner and we can update it later. But the reason I'm doing it, I'm creating a brand new object here, is if I use the original object, it might, I want a copy basically. So, because I don't want to end up breaking it. Yeah, I want to actually update this value, and I don't want to actually modify the original data. So that should be fine. Now we want to iterate over the points. And I guess what we can do is do top left corner dot x equals math dot, let's think, the minimum value of point dot x, because yeah, it needs to be the lowest value. Even if it's negative, goes off the screen, that's fine. So the minimum value of point x and the top left corner dot x. So if we've already got the smallest thing, then it'll just reassign it here. If we find something that's smaller, we'll use it. So we can do that for both the x and the y. And in that way, we now have the top left corner. So now what we need to do is use that top left corner to kind of calculate where we need to move our shape to. So we need to calculate a move offset. Move offset equals, so let's just think then. So I've passed in this offset here, and that's kind of what I'm going to use as the kind of, I want a border essentially around the thing. I don't want it to be butted right up to the edge of the canvas. So this, I think, let's just give an example of how I would expect this to actually work. I would go points, and let's pass in, say, x10, y10, 0.5 actually, because we need, oops, we need that so that we sit on the middle of the pixels. So we'll pass in that as the top left corner sort of origin location that I want to use as my boundary. So now here, what do I want to do then? So I can take this top left corner, which represents, so let's just say it was minus 100 minus 100. What would I want to do with that? What I would want to do is take minus 100 minus 100 and add on 110 in both x and y for all the coordinates, which would shunt down the whole thing into the canvas with a 10 pixel and 10 pixel border at the top and the left hand side. So So I think what I can do here is do subtract points and do top left corner and the offset. So yeah, that would make sense. So say, just for argument's sake, let's say we had the top left corner of the fractal pattern was minus 40 in the x direction, minus 20 in the y direction. So to move that so that it has a border of 10 pixels and actually be visible on our canvas, we'd need to add on, so it's minus 40 and minus 20. We'd have to add on 50 for the x coordinate, minus 40 plus 50 is 10. And in the y direction, that's minus 20, we'd have to add on 30. So yeah, minus 20 plus 30 is 10. So that shunts it down the amount that we want. So this line of code effectively calculates the offset value. So where it was minus 40 and we've passed in here a value of, well, let's just pretend it was 10. Minus 40 subtract 10 is 50. So that's how we get to that offset. So in the y direction, minus 20, you subtract the 10, that gives us the 30. So this now contains an offset value that we can now use to add to all of our points, and that will then shunt the whole thing over into the place that we want. So let's do it. Point of points. Const new point equals yeah, so we want to calculate the position of the new point. So we can do subtract points, point, move offset. Okay. Oh, don't know what I did that for. And do point.x equals new point.x. Point.y equals new point.y. Okay. Okay. So hopefully then, with this, it should put it in the right position. Yeah, so that actually looks good. Although it's clipped off the bottom, that's only because the canvas isn't big enough. But you can see it's moved whatever we had before into our viewable canvas window with this sort of 10 pixel spacing here. So another cool thing we can now do, because we've got this segment length, I can change this to make it smaller. And look at that. How cool is that? And it nicely calculates the position for us. So let's crank up the iterations. Why not? Let's go with 12. It's going to be quite big now. So let's reduce the segment length and see what it looks like. Oh man, that looks awesome. We now have a fully functional paper folding algorithm done. So I think the last thing to do is a bit of a flourish. Should we give it some color? It's green, but I think we can get creative with this color now. I think it would be cool to express the color in relation to the length of the line, or how much of the line we've drawn. So we can calculate a value which represents the percentage of the line that's been drawn, let's say, and set the color based on that. So let's do const we'll calculate a complete amount, which equals I divided by points.length. So that'll be a value between 0 and 1. So we can multiply this by 255, which will give us a nice... Actually, there's an even better way of doing this. We can use hue, saturation and lightness. So we can do it. So we still need that complete value, and we'll express it as a value between 0 and 360. So you need that 360. So this 360 is for the hue part of the HSL color wheel. So 360 because it's a wheel. And what we can do here is do HSL open bracket. It's just and we can do that complete. So that's the amount in terms of the color wheel, and then 100% for the saturation and 50% for the lightness, which is bang in the middle between 0 and 100. 0 is black, 100 is white, so we want pure color. And actually, I think that should work. Oh, I wonder what this is going to look like. Epic. That looks great. I'm chuffed with that. Let's go a bit crazy. Segment length of 4. Ooh, up to 16. I don't want to go too much because it's oh man, that looks great. So yeah, this has been fun. I love the way these patterns interlock with each other. It's like a self-interlocking shape or something. So there we go. Maybe we'll create that as 3 so that it fits on the page. Nah, let's make it bigger. Increase the size of the canvas. Height 1200. Yeah, there we go. Oh, it's behind my head, I just realized. Awesome. So there we go. Paper folding algorithm. That looks great. I think what I'll do is I'll post the source code in the description, so you guys can have a closer look. But you can see it's quite a simple little thing, you know, less than 100 lines of code, less than 90 in fact. Very simple but very effective. So yeah, that's me. I'm the Random Coder. Thank you for watching, and please subscribe if you liked what you saw today. Thank you very much.